Hi, Happy New Year to everyone. I hope you had pleasant holidays. As you can see, I'm sitting at a table with a lot of stuff on it, and these are not my Christmas gifts, or maybe they are, I don't know. This is mostly, as you can see, having to do with cables, and this is the part of the new Powerwall upgrade, and it is mostly a performance upgrade. What does it mean, performance upgrade? You know, if you're talking about active storage systems, you typically name it by capacity and the discharge and charge performance. So let's say a Tesla Powerwall, it used to be a 13.5 kilowatt hour, 5 kilowatt charge and discharge system. I don't know, maybe they changed already. So my Powerwall, as it stands still there today, is a 18 kilowatt hours, 3 kilowatt charge and discharge system. And after this performance upgrade, it will be a 18 kilowatt hours, 4.2 kilowatt charge and 5 kilowatt discharge. So it's getting quite powerful. Why do I have to change so many things here? First of all, I'm surprised how it developed, right? I would never have thought 2 years ago that this project is going to grow so much. After this, there's only one option left, and that might be adding some cell capacity, and that will then be it. In the last video, we were talking about how to make the variable charger work, and I have ordered new PCBs. This is all laying here already at my table. I had to wait for some of this item for some time, but now everything is here. I have prepared most of this stuff already, like the fence leads of the BMS, for example, data cables, etc. And I'm also doing this briefing now a day before I want to do the job, because I just want to keep the downtime tomorrow as short as possible. So tomorrow in the morning, early in the morning, when the battery is discharged, I want to take it offline and then install all of this. As soon as it's installed, software is uploaded to the controller, we can start testing. I think you have waited long enough. Let me show you what I have on the table, and then we will take a short look at the Powerwall. Right, let's look a little bit in detail what I have here. So my new version 5 controller board, a lot of changes, especially with the connectors. And we can now, of course, accommodate this 8-channel relay board, and here my digital potentiometer, especially for this project. You see the adapter board on the down and the potentiometer just plugged in, and now I can just use my connectors on each side to connect there. Okay, then of course data cables. There will be a new lid on the controller because I have an extra display here, a little bit different layout. Then a big part of the performance upgrade is the new BMS. I already extended the voltage sense leads, and this is a DALI 16S 48 volt 200 amp. So we can charge 100 amp and 200 amp discharge, so this will not be maxed out, only at charging possibly. Okay, then a lot of cables, also some AC connection cables. These are for the sun inverters, especially for the 2000 watt ones. The cables which come with the inverters, they are only 3 times 0.75 square millimeter. This is for 2000 watts, quite a little bit small. So I bought now new cables which are 3 times 1.5 square millimeters. So this is only for the 2000 watt. The 1000 watt inverter is no problem with the small cable. A few new breakers. I had to make some new bus bars because last time unfortunately I got a little bit too thin ones, because here in Thailand they use measurements, sometimes metric, sometimes the imperial, and yeah, I mixed up mils with the millimeters. Then new jumpers, so this time 25 square millimeters. They will replace the 16 square millimeters on my battery pack. So all of this can handle much higher currents. And yeah, let's look at the Powerwall and I talk you through what has to be done there. So yeah, in our Powerwall, door number 1. So initially the controller has to come out. The lid will be changed, and I also need to take out the whole box because I have to put the new relay board inside, have to make a few holes. Then of course here there will come a new breaker. This is a 100 amps, it will be a 125 next. Then I will replace some of the cheap breakers here with the Thomson quality breakers. So this one will come out. Here of course all these battery main cables will be new. The rest will stay the same. Yeah, let's continue at the battery pack. Here my old BMS will come out and the new one will be installed. And yeah, as you can see, I think this BMS is about a quarter of the size of the new one. This was a 70 amps charge and discharge BMS. The change is mostly on the jumpers. They will be shorter than these ones, and of course the bigger diameter. So there's a few jumpers here, a few bus bars, as I said, need to be changed. So basically all this small wiring from the BMS has to come down, and my also voltage monitor, and yeah, then be rewired. The last door, our new compartment, the new electronics. I have already just put the inverter and the charger on the back wall, but that's all. They need to be connected. DC connection is done, but still these temporary cheap breakers will go, and will be also the Thomson breakers. Yeah, the new AC cable, this is still the original one, the thin one. AC needs to be connected. This one goes to the controller, one relay there. Yeah, then this is already the connection for the potentiometer, so the potentiometer box will come here somewhere. So a lot of things to connect. This will take a while, and I hope then that latest tomorrow by midday we can run and test the system already. Today is the day when the next performance upgrade will be done. I have written a checklist. I have all my items here. I could already cross off a few items from the list yesterday. I just laid the AC wiring already, so this we don't need to waste time anymore today. Let's take the Powerwall offline, turn off the controller, turn off all DC, AC, and yeah, final thing to do, battery is off. Now everything is dead. So what will be done is now remove the controller, take off all the wiring, and then we are working on the DC here, so removing all those small wires and I will then rebuild this pack so that it can cope with the new performance situation. We will then already install the new BMS, new breakers, yeah, jumpers, wires, bus bars. Let's do this, and in around 1 hour this will already look quite different here. The battery is secured, plus and minus is removed, and now I can work on this safely without causing some big short somewhere. Just to show you the difference in the size of the BMSs. So this one, the old BMS, a 70 amps charge and discharge BMS, and the new one, 100 amp charge, 200 amp discharge. Quite massive. So before I'm replacing the last bus bar now, let me just show you the difference. So the right bus bar which you see here was actually never supposed to go on the system here, but it was just a mix-up because of imperial and matrix measurements which they use here in Thailand, and I was not aware of this. So now this bus bar is going in here. It's 3 millimeters aluminium times 2.5 centimeters. So still the thin bus bar was no problem at 60 amps. Of course, bus bar like this can still carry a lot of current, but this will be fixed now in future. Now to the jumpers. These are the new jumpers, 25 square millimeter, so they will connect one side to the other, and this time they are just as long as they need to be. Jumpers are all attached now, and the next thing I want to install is the BMS. So it will be like this here. I have my own temperature sensor for my monitoring app, and yeah, there's another one here also, but this is meant for ambient temperatures to avoid charging during sub-zero temperatures or something like this. Here in Thailand I don't need this really. And yeah, so next I'm going to connect these other wires here to the battery and then to the breaker. And after this is connected, I'm going to attach the sense leads to the battery pack, and then we are going to check the voltage and plug it into the BMS. Almost 4 hours are gone. Yeah, I finished the DC side, so from DC main bus through the battery BMS back to the bus. Now I'm going to check all these voltage sense leads of the BMS, and if they are correct, I can then plug this into the BMS, and we can then see if the BMS will switch the voltage through or not, because I heard that these smart BMSs maybe need some sort of activation via Bluetooth or whatever. I have no idea. So initially it's important now to check if this one is okay. I will just go through every step, so until now everything is fine, and then we are going to see if we have voltage on our breaker after we plug this in. And yes, 50 volts at the end here. All steps have been confirmed correct. Let me try and plug in this BMS. I did not connect everything yet. This is my private voltage monitoring. I did not touch yet because it's not important for the operation of the Powerwall. I just don't want to spend another 30 minutes to do those leads again. So let's plug this in. Okay, connect it inside there. Okay, so do we have voltage here right away? That's the big question. Or does the BMS need some sort of activation? So minus plus, yes, 50.6 volts are present here. Very nice. You see, I had to change this setup a little bit. Before I had my shunt here after the breaker, and there would not be enough space because of these massive cables here. So I moved the shunt down to the battery side, and yeah, so it will work like this. Two new breakers here, two new breakers at the other compartment for the inverter and for the other charger. So DC side is now fully connected. The next thing I have to do now, and the last thing, is remove the controller and yeah, change all these devices here, the screens, etc., LEDs, put it to the other new lid, and yeah, new PCB, new boards inside, and we can connect everything, and then should be finished. Okay, I have just transferred the last device from the old box to the new one, to the lid, and this is now how the face of the new controller will look like. We have now 3 displays, one extra. This one is just meant to show the status of the charger number 4. I have now to set up also the controller. I already flashed the new software on it. And yeah, this have to come off. The new board have to come inside. And when this is done, we can go back to the Powerwall and connect everything. It's 2:30 and the day is almost over. Okay, now I've at least installed the new controller, so all the relays are connected. I will put the lid on now, and then we're ready to start up. And the hope is that this will boot up and everything will at least work as planned. It will never work perfectly the first time when you start up new code. There are a few bugs in the code anyways. And it's stuck. We have a hang start right at the beginning. So this is after initializing the screen. So it might be maybe at initializing of some new hardware inside, like the potentiometer, etc. So now you see another startup. This is now caused by the watchdog, and yeah, so we have a hang start right at the beginning, as many times when you do something like this. So okay, I have to look over the code again and then see what can be the fault here. Okay, right, it's a bit later now, and let's do another try. Okay, we have a system start now, and it's connecting Wi-Fi already. Blink. On the down we can see a sort of startup bar, Okay, no cards, it's okay. And it started up. So what was the issue? I found out that this one, you see now it's blank. When you had looked closely before, you saw some weird picture there. This OLED display seemed to not have survived our transition. The reason is it is glued on this lid here, so it was glued on the old one already, and I had to remove it by using hot air and then glue it again in this one, and this seemed to be not have worked out well.